Welcome to the DIY Honda Garage channel. DTC P2245 indicates a low voltage condition in the air-fuel ratio AF sensor's VCENT circuit for sensor 1 on the 2022 Plus Honda Civic. The AF sensor plays a crucial role in monitoring the air-fuel mixture sent to the engine for optimal combustion efficiency. It measures the oxygen content in the exhaust gases and helps the powertrain control module, PCM, adjust the air-fuel ratio to reduce emissions and improve fuel efficiency. The VCENT line specifically relates to the sensor's voltage output. When the voltage falls below a specified threshold, it indicates an anomaly, prompting the PCM to store the DTC. Diagnosing this error involves inspecting the circuit and the components involved, notably the AF sensor itself, the PCM, and any associated wiring connections. The DTC P2245 error occurs when the powertrain control module, PCM, detects that the voltage output from the AF sensor's VCENT line is lower than the predetermined specifications. The AF sensor, located before the catalytic converter in the exhaust system, provides critical feedback that is used to manage the engine's air-fuel mixture. If the VCENT line voltage is abnormal, it signifies that the sensor is not functioning correctly, which could lead to poor engine performance, increased emissions, and decreased fuel economy. The PCM continuously monitors this circuit, and upon detection of the low voltage condition, it logs the DTC and may activate the check engine light. Proper inspection requires a detailed analysis of the sensor's wiring and connections, as well as the PCM's functionality, to pinpoint the precise source of the fault. Potential causes of DTC P2245 include a shorted wire within the VCENT circuit, a malfunctioning powertrain control module, PCM, or a defective AF sensor itself. If there is a short in the wiring, the voltage can drop below the established threshold, triggering the DTC. Furthermore, if the PCM is unable to interpret the signals from the AF sensor because it is faulty, the error code might also be generated. Lastly, if the AF sensor, which directly measures the air-fuel ratio, fails to deliver the correct voltage due to internal problems, it may still result in the same low voltage reading. It is important to systematically inspect each of these components during the troubleshooting process to identify the actual culprit behind the error code. Symptomatically, DTC P2245 may manifest as an illuminated check engine light, indicating that the ECU has detected a problem. Drivers might also experience poor engine performance, including hesitation during acceleration or unstable idle conditions. Since the air-fuel mixture is not being adjusted properly due to the sensor's failure, the engine may run inefficiently, leading to noticeable increases in fuel consumption. In some cases, drivers may not immediately recognize these symptoms until performance degradation becomes significant. Consequently, it's essential to address this DTC timely to avoid more severe engine damage and to restore optimal vehicle operation. The first troubleshooting step for diagnosing DTC P2245 is to start the engine and hold it at a steady 3,000 RPM without any load. This should be done with the continuously variable transmission, CVT, in park or neutral for manual transmissions. Maintaining this RPM allows the engine to reach a stable operating condition and ensures that the radiator fan activates, which is part of the normal operation. This step is significant as it provides a baseline to observe the behavior of the AF sensor during different engine conditions. After the engine has reached this state and the fan has turned on, the technician can let the engine idle and check for any abnormalities in the sensor readings. The second troubleshooting step involves disconnecting the AF sensor, sensor 1, 6P connector, and the PCM connector E, which consists of 80 pins. This disconnection is crucial as it isolates the circuit for inspection. After disconnecting, the technician should examine the VCENT circuit for any signs of shorting or grounding, which could affect voltage output. This step helps determine whether the fault lies with the wiring or the sensor itself. The goal of this inspection is to ascertain the integrity of the circuit prior to conducting further diagnostics of the PCM and the AF sensor to isolate the root cause of the low voltage condition reflected in DTC P2245. In Step 3 of troubleshooting DTC P2245, the technician should conduct a VCENT short inspection. This involves checking the VCENT wiring to see if it is shorted to ground, which would indicate a fault in the circuit that could cause the low voltage issue. Using a multimeter, one can determine if the circuit is open or shorted, and if there is any abnormal resistance present. Ensuring that normal conditions exist without any shorts is essential to confirming that the previous steps did not yield any circuitry anomalies. If a short to ground is found, it requires immediate correction. If it appears normal, the next steps will further confirm the integrity of the PCM and the AF sensor. Step 4 involves a detailed inspection of the powertrain control module, PCM. Before proceeding, technicians must confirm that the external circuit leading to the A5 sensor is functioning correctly. This step is paramount, as an improperly functioning PCM can lead to misinterpretation of sensor data and erroneous DTC storage. By conducting voltage tests of the A5 sensor while the engine is running, the expected output voltage must be verified against the specifications mentioned in the service manual. Upon verification, if the output voltage remains below 0.2 volts, this points toward a faulty PCM, or possibly the A5 sensor itself, necessitating further analysis to pinpoint the failure. In the final troubleshooting step for DTC P2245, if previous inspections confirm normal operation of the PCM and external circuits, an inspection of the AF sensor itself becomes necessary. This includes checking the output voltage from the sensor while the engine is in operation. If the measurement is found to be below specification, it indicates that the AF sensor is, indeed, the root cause of the DTC. A replacement may be warranted based on these findings. It is essential to replace the sensor with an OEM equivalent to ensure compatibility. After replacement, the system should be cleared and a road test performed to confirm that the DTC does not return and that engine performance is restored. After completing the necessary repairs related to DTC P2245, it is crucial to perform final verification steps. First, the technician must clear the DTC from the powertrain control module, PCM, using a diagnostic scanner. Following this, a comprehensive test drive should be conducted under various conditions to validate that the vehicle operates correctly without any recurrence of the error code. During the test drive, the performance should match expected levels, and no warning lights should illuminate on the dashboard. If the vehicle operates as intended, it confirms that the repair efforts were successful. Documenting this outcome ensures proper service history and can assist in future diagnostics if needed. Preventive maintenance is critical in avoiding issues like DTC P2245 from arising in the future. Regularly inspecting the wiring harnesses associated with the AF sensor can help detect any wear or damage before it leads to operational failures. It is also advisable to monitor the performance of the AF sensor to ensure that it functions efficiently over time. Using high-quality, OEM-recommended parts when replacements are needed ensures compatibility and longevity of the system. Additionally, maintaining proper engine operation and addressing any performance issues promptly can prevent further damage to the AF sensor and its associated components. Keeping a routine check on these factors will help ensure reliable vehicle performance. In conclusion, understanding the role of the AF sensor is pivotal for diagnosing DTC P2245 effectively. The sensor aids in measuring the air-fuel mixture necessary for optimal combustion within the engine and directly affects both performance and emissions. A systematic approach to testing, including inspection of wiring, PCM, and the sensor itself, is essential in identifying and resolving the underlying issues. Following each diagnostic step meticulously facilitates accurate repairs, helping to maintain engine functionality and efficiency. Furthermore, incorporating preventive maintenance measures into regular vehicle care enhances reliability and reduces the risk of encountering similar issues in the future. Keeping these practices in mind ensures a smooth and efficient running of the vehicle. Please like and subscribe to the channel. See you next time!